होप इट इज़ वर्किंग. सो ये 10 फीट पे आ रहा है यहाँ से, और we'll have to use from here. We already have a beam here, so we'll just check out what is the distance. It's 2 feet. 2 feet it is equivalent to 600 mm 0.6. So I'll add one. It just comes and sits on top of this. It's there, right? So we are just keeping one beam here. Are there any secondary beams? Yes, there is a secondary beam here as well. See, normally I'm just making secondary beams for sake of this video, or else you don't have to make when you get quite experienced on few stuffs, you don't have to make any uh, secondary beams, because the secondary beams are like, you don't need to make any models for them, they just exist, that's it. There is no, it's not a major beam, right? क्या आएगा ज़्यादा से ज़्यादा? See, it is just getting equal, divided into 2, so I'll just divide this into 2, right? Fine. And what other things are we getting? We are getting this stuff, it's just u, right? It's just equivalent to this. What happens in practical scenario, inside scenario, you already have this beam, this plinth beam, it just gets continued here. You already have this beam here, and you will just have a L shape of beam here, that's it. That is plinth beam. It's just getting connected here and here. It's getting connected to this plinth beam, it's getting connected to this plinth beam. Anyways, I'll show you the side. We'll be going up for line out for this building also. So let's get back to this. So what we have done, we have done the plinth beam. We have also plotted the secondary beams. So secondary beams will not take the moment, because it is resting over the main frame, main beam, right? So you'll have to release the moments here. So how you have to release the moments? You have to go for the specifications, you will have to go for beams, and there is this option called as release. You will have to release the moment. You don't have to release torsion, you will have to release the bending, the out of plane moment, and the main moment, that is mz. और ये क्या है mx, my, mz? That is very basic stuff. I'm sorry, you'll have to figure it out for yourself, or else you can comment on the video. I'll be happy to share you that, right? Because when you are a structural engineer, I believe that you will be knowing what it is, right? And I might also be, see, structural engineering is the, everyone has a different thoughts, it is a thought process. I might be using different thought process, you might be using different thought process. So we'll be, यहाँ पे तो नहीं आना चाहिए, यहाँ पे आएगा. So you have released the moments here, you will have to release the moments here as well. So you are releasing the moment, so that what happened to this pin, it is not getting selected itself. Okay guys, so you have released all the moments. I hope it is getting recorded, right? Plinth beam is all ready. We'll save this first, we'll come back. So plinth beam is done, and now we'll select all the columns. The height of the slab is 11.5, clear distance is 11 feet. 11.5 is equal to 3.5 meters. We'll just raise it on top. Uh-oh. So we'll have to do one thing. Parallel to Y, we'll have to seal this way. We'll have to select all the nodes, come back, select, go on top, 3.5 meters with link, done. Yeah, so we have come on first floor now. फर्स्ट फ्लोर पे आए हैं, so we'll work on this floor now. We'll work on first floor. फर्स्ट फ्लोर क्या कहता है? So we have this total area for terrace. So similarly we'll have to go with the main beams here. We'll start with the same basic thing, left to right, left to right, left to right, top to bottom, top to bottom. Yeah, left to right. We don't need this beam, so we'll be skipping this. Left to right, top bottom, left to right, top bottom. You already know everything here. And 5 feet pe we are getting a secondary beam. Top to bottom, 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 left to right, left to right, left to right, left to right. There is a staircase in between, so we will not be using the. And for 5 feet yani it's 1.5 meters, right? And 3.35, 7 feet, that's 1 point. Yeah, so we'll come back to the geometry here and here. Okay, come on. 1.5, 3.5, 6.2, no, 2. Okay, so we already got this beam here. Left to right, top to bottom, and since it is the secondary beam we are releasing moment. You can release the moment here also. If what happens if you release the moment here and here for both beams, when you run the model, it will show you warning saying that there is a joint instability because it is getting released at both end and it's unstable, it's just falling down. So you don't have to do that, right? So majorly we have done with two floors. We'll have to add the loads after all. So this is plinth beam ground floor, so this is one slab. Now again we'll have to go on top for slab. That is with 3.5 again. Right. Since we do not have any further plans, so we will connect all the beams. If in case in future if there is any plan going on, so it's better you make the provision for beams already, so that you are all set for constructing new floor on top. I'm just connecting all the floors, all the columns with beam. Alright, so we are all done with this. So this is how the model looks. So now we'll start with the properties. We'll define each and every member. So with the experience, we'll just assume column to be 450 and 380. Plinth beam will go with 300 for secondary, right? 150, 300 also for secondary beams. And we don't have any 21 inches stuff, right? The maximum thing we have got is 16 feet. So we can finish it off with 18 inches beam. So let's start with the plinth beam. So all the secondary beams, see, ground floor, this does not take a lot of weight, this doesn't take a lot of weight, right? So this one and this one, we can go with 6 inches, and this one, yeah, we'll go with that thing, with this stuff, this stuff, this stuff. What is this? The length wala? Okay, yeah, that stuff, and this foyer wala one thing. I don't know why it is not getting selected. Yeah, we'll go with this. Let's see how it works. And 9 by 12, we'll go with 9 by 12 for these columns. since these columns are quite big, these beams are quite big, so I'll be going with 15 inches for them. Let's see what analysis says, what is the moment there. I don't know, there's some issue with the not getting selected, man. This is what happens when you don't buy a genuine software. So you'll have to find a workaround. Yeah. So 9 by 15. So plinth beams have been assigned with the properties, right? You have saved it. Let's go with first floor. This one takes a lot of weight, so I'll go with 18 for these 3 beams. Guest rest I'll go with 15 except these two. I'll select these 2 by 9 by 12, right? And rest others I'll go with 9 by 15. Right, do we have any other 12 feet wala beam? We have got 11 feet also. Let's go with this for now. We can anyways change it later. We are going on terrace. Same thing. This 18 wala, this beam, because the span is huge, so I'm thinking of giving it 18. So all these other 15 I'll give. What is the distance between this? 13, 13, 13. Fine. Okay. So we have given the material properties. So let's give material property to the columns, right? I've already given out a few sizes for it, right? So this is 9. So there are two types of column which I have selected. One is 915, 9 inches 15 inches, that is 230 by 380. Another is 9 inches by 18 inches, that is 230 by 450. So let's first finalize with the 18 inches. Here C1, C4 and central columns C5, C6, C7, C10, C11. These are the central main columns, that is 9, 18. C1, C4, let's select all those. C1 selected. C1, first select with this C1. C4 assigned. Yes, okay. C5, C6, C7, C5, C6, C7 assigned. Okay. C10, C11, C10, C11 assigned. C14. I guess C14, C15, these are 15 inches. Yeah. How about C12, 15, C16, this is already 15 inches. Okay, fine. So how many? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Fine. And rest others are C15. Okay, fine. So we have already given the property for columns, but if you see, the orientations are already different here, so we'll have to change the orientations now. For that we'll have to go to specification. Sorry, we'll have to go to here only. We'll have to go in properties, beta angle we'll have to change decrease to 90. Fine. And we'll have to select कौन से column. If you press Ctrl 1, you will get this orientation of columns. C3 एक एक करते चलते हैं. C3 changed. C5 changed. C5 C6 C9 C10 C11 C9 ना ये है C9 C10 C11 C9 C10 C11 changed, and then C13 C16 C13 C16 changed, right? So we have already changed the column position. Let's check it once again. C3 है, इसमें C3 है, इसमें ये एक है, इसमें ये 2 3 है. I hope this is not getting disturbed, right? इसको ये छोटा होता है क्या? No. I'm thinking it to keep it somewhere where it does not get affected. I want to make it little smaller too. It's not happening. It's okay. Let's not get distracted. So we have already given the properties and we have changed the orientation. We were checking the orientation. ये हो गया, ये भी हो गया, ये 3 हो गए, yes, ये 2 भी हो गया, yes, fine. Finally we have done with the modeling and we have assigned the properties, and let's see how our building looks. So this is how it looks. Fine. This is the framework. You can see यहाँ पे है, देखिए, you can see here, this is the secondary beam, right? So secondary beam orientation, I guess we'll have to change the orientation of secondary beams and all. We need to have the beams that way, so orientations of beam should also change. See, it is getting flat. This side should be 9 inches and this side should be the deeper edge. It gets, now this is where it gets complicated. We will have to keep the columns separate or else it gets clashed. Let's do one thing. We'll keep the columns separate. Why am I doing this? I want to change the beams orientation. So we have already changed the orientation of column and the property of column and beam, since they both are having same uh, properties, that is sectional properties, it will have to make a separate property for this. ये सब मिलके 5 हो जाएंगे. Everything will be same. So you can just skip this little bit. There is a slight adjustment going on. Fine. Now you will get to know why it was being done that way. You will have to keep saving, man. Sometimes it just crashes and it just goes away. See, now you will have to change this orientation by changing here itself. सब तो चेंज नहीं कर सकते हम लोग, ऐसा चेंज करना पड़ेगा. Now let's see. Control 4. This is how it should look, right? Now it comes. This is how it should be. Fine. So let's continue. So कहाँ पे थे हम लोग? Geometry आ गया. Properties we have given. We are done with properties. Material, it's already given. Concrete. Specifications, we have used specifications to. Supports we have already given. We'll have to go with loadings. So for loadings, you know that I'll have a separate कौन सा फाइल निकालूं आपके लिए for loading. I'll use this. Let's come here, right? Estimation RCC structure load calculation. Let's come here now for a while. We are working on this client, so let's come for load calculation. Right? So density concrete, height of brick, we know that we have got 11 feet, right? 11 feet is equivalent to 3.35. so you'll have to deduct the beam thickness and all, so let's go with 3 feet 2.3, so 13.8 will be the brick load, right? So let's start with the dead loads with 13.8. You'll have to use minus 13.8 as brick load, and plastering वगैरह सब होके it comes to around 15.64. so let's go with 15.64, right? 15.7. so it is including plastering. Fine. And height of brick wall, for this is for secondary walls. Secondary wall we are getting somewhere around 10.84. it is 11. Secondary wall we already have got secondary wall, so now we'll have to give 11 kilonewton per meter weight also, minus 11, right? And next, what all do we have got? That's it for now. So this, let's start with the length, right? Length, main wall, what all main wall we are getting? This everything is main wall except the secondary, which is starting from middle of the beam, that is secondary beam. Rest all other is having 15.7. so I'll add actually we'll have to give the secondary beam here also, which is already given here. ये वाला जो है we'll have to give here this, but it's a lot of jagmag, so I just skip it. You don't need to do, you need to do this, but I'm just skipping it. I'm considering it to be straight. यहाँ पे बहुत दिखाया हूँ मैं आपको. These walls, these will get 6 inches. I guess this is getting selected twice, right? Yeah. So we'll have to toggle this width there. Fine. So you can see the loads if you increase the level. kg per meter. You can see it getting raised, right? So ये load, this is the load that is being put. So this is how it looks like. Okay, fine. Let's go with the first floor also. Where is save? Let's go with first slab. There is a lot of stuffs here. Same thing. This and this will not get included. 15 and these two. Luckily we don't have any other loads here, or else it gets too much messy, right? So we are going on terrace. Terrace we don't have much load, but we still will still consider the main loads. Might be in future if they extend, so we should be ready beforehand, right? We have already given all the loads. We should also give self weight here, -1 self weight. We'll have to assign to all. Now next step is you have to make groups for flooring first slab. So we'll have to highlight. For that we'll have to select those only floor. This is our first slab. First slab, majorly everything is two-way slab, right? Everything is two-way slab. This stuff, this stuff, this stuff, this one, this one. This is open anyways, right? So you'll have to associate. So it gets assigned. So what is the loading for two ways? What is the loading for slab? Considering 150 mm, pressure due to slab is 3.75. How did you get this? You know that 0.15 into density of concrete 25, 3.75. Waterproofing वगैरह करके it's 4.85, but we don't use waterproofing, we use floor finish. Floor finish we'll be getting somewhere around 1 kilonewton per meter square. We'll be taught like 1 kilonewton per meter square. 1 kilonewton is 100 kg. 100 kg per meter square, 10 kg per square feet. Maybe we'll get somewhere around 3.75 plus 1 for flooring, that is 4.75. So we'll add floor load group first slab minus 4.75 add. So you can see floor load being added, right? Let's go to second slab. We'll create second slab. When the project gets model gets too complicated, you'll be ending up with a lot of groups here. So you have associated this floor second slab minus 4.75 because you are making sure that if they are constructing anything in future, this should not be getting added. So I'll just make sure that you'll have to do that so that you don't get this. Fine. Okay. So we are done with the loads, we are done with the slab weight and all. Now we'll add live load. Live loads are like sofas, the bed, right, and the people playing around. It's -2. We'll have to consider -2. We have considering -2 for all the slab live load. Now we'll have to go for load combinations. What is load combination? 1.2 dead load plus live load. See, I'll tell you, in college we'll be taught we'll have to go for 1.5 dead load plus live load, the load combinations which is there in IS code. But in market, I'll tell you, people don't even consider 1.5. 1.5 is like the heavier side. Nobody goes for 1.5. Where is my load combinations? Where are the load combinations? It should come here, right? Okay, maybe I have done something related to the load numbers. I should not have done that. With 1.5, right? So you are done with the load combinations, you are done with the loads, you are done with all the properties. Loadings you have done already. सेल्फ वेट चेक हो गया है, लोडिंग सब तरफ आ गया है, ब्रिक लोड आ गया है, स्लैब लोड आ गया है, लाइव लोड आ गया है, फ्लोरिंग का आ गया है. एनीथिंग डू वी have to keep? Just checking. This is done, right? So this is how the modeling with the loads have to be done. So let's go for analysis. Let's see what it says. So before going for analysis, you will have to give this command and run. There shouldn't be any errors, I believe. If any, let's say there is an error here. What's the error? Sometimes if I use the internet, so I'll have to go for the editor inside there is some stuff going around which I was doing, right? 1 and 2 load combinations, वहीं पे कुछ गड़बड़ हो गया है. This is the gadwad he is talking about, so we'll have to delete this, and the error is gone. I thought मॉडल चला गया लगा मेरे को. Let's see. So the model is running. Okay, done. So let's go with post processing. Apply. I'm sorry, I forgot to add another load combination which I normally do, that is 1 and 1. I like to know how it is going, because 1 and 1 is quite necessary for foundation design. What is the reaction? Static reaction. See, you can see. So total weight is 7 tons. That is dead load. Total weight is 7 ton. 7,000 kilonewton. 7,000 kilonewton यानी 706 tons of dead load. The building has 706 tons of dead load. And 50 tons of live load. What is the reaction? Oh my god, reaction. Okay, that is for 1.5. Highest is 803. For 803 you don't have to worry a lot so see, the central column is getting 803, that is 1 2 3 4 1 2 3 4 5 6 7. C7 is getting a lot of weight. C7, this column is taking a lot of weight, right? That is taking around 80 tons of weight. So यहाँ पे 80 tons का weight आ रहा है. So you'll have to design the foundation for 80 tons of weight. It's huge, man. Structural engineering is quite very much responsibility, man. There's a lot of responsibility. So let's see the reactions which we need for our design. Now we'll be next going for the foundation design. Recently I did a project where I have used and I have done a template for it, right? Foundation design RCC. Let's take this template for our project. So this is the Excel sheet which I have created for myself. So this is the foundation design checklist, right? So let's go with the okay, let's take the cursor and we'll just move around. We'll keep it here so that we'll be ready for foundation design. Yeah, see, so this is the load for, this is live load, so we need it for dead load and live load combination. Yeah, so this load, whatever it is showing, so this is the reaction which we'll have to design the sizes of foundation, that is length and breadth, right? This is for the serviceability condition. As you can see, it's 300 here, 550 here, 570, 330, 502, 702, 803, 500, 400, 500, 533, 400, 270, 393, 3. I guess if these two are quite low, 274 and 275, these two. So if that is 274 and 275, I guess we can go for 12 inches column here rather than 15 inches. And for these two we can still try for 12 inches, these four, and others with 500 will go for 15 inches, and more than that will go for 18 inches. These two will go for 18, these four will go for 12. Let's see, right? We can go for 12 there. 9 by 12, 300, 300, 200, we can go for 12. We'll go for 12 here. C13, C1, C3, C4. I have gone with 18 inches, man. This I have gone with 18 inches. Why? Because of this huge stuff. I guess I'll go with 15 inches for these two. I'll go with 12 for these two. So we'll be shifting our whole stuff after structural designing. We have initially we had assumed this, right? So now we'll get a clear idea of what we'll have to do. So I'll take a screenshot of this. पूरा लेना पड़ेगा यार, वरना you'll be struck. So this is the reaction. So this is the reaction, footing reaction, we'll rename it. So we don't need that now. This sheet we don't need, we are done with this sheet, so we'll have to go with this. So let's go with 803 and let's see how what the size of footing comes. 803. Let's go with 810. And what is the fx and momentum? See, fx are quite low, 12 maximum है, मोमेंट भी 7 मैक्सिमम है, तो मोमेंट 7 7 कर देंगे, ये 7 कर देंगे, ये 12 है, 15 करते हैं दोनों को. I guess we'll have to go with the middle, we'll have to go with 6 feet by 6 feet. So 6 feet, that is 1.8. 1.8, 1.82 to be precise. And depth we'll have to go for the 1.5. this is for depth, so I'll take the location, I'll come here, I'll go here, and I'll make a color saying this is for depth, right? 1.5 dead load plus live load combination, and increase the font. This is for below 1205, right? I'll come to this. First I'll finish off this 1205, and 18 is the highest, so I'll go with 20. Momentum we have 11, so let's go with 11. 10 hai 11, fine. What is the column? Now let's come here. Column size are 450, 230. Density of size, column foundation, cover 50, max dia in foundation 10, yes 10 mm. Net bearing capacity is quite good, as they say, it's quite good, so let's go with 250. Depth of foundation we have assumed 6 feet, and cantilever momentum, I'll explain this sheet someday in another video. So we are getting quite unsafe here, 294, so it's going for 280. I don't think so that's it's still manageable, both manageable hai. It's quite manageable, 294. If we go for 288, 26, acha, I see. Oh, okay. 288 and 274, there's a it's quite there. Technically you shouldn't be going for this, but practically you are not going to achieve 810. 810 is being achieved when everything goes as per the design, everything goes as per the weights and all which you have considered, and most probably it doesn't happen most of the times. Net bearing capacity, you are assuming it's 250, practically it will be very much more than that. There is a lot of factor of safety which is going around, which comes out to 250, it's more than that, so you don't have to still consider that into your design. You don't have to take out all those factor of safety, so it's better if you design for 274. So you'll have to slightly increase your sizes, 1.85, 1.85, quite there. Allowable is 277, 1.9, 1.9, so you are safe. 1.9 is 6 feet, 6 feet 23, 6.23. So what is 0.23? 0.23 is 3 inches, I guess, right? Yeah, 6 feet 3 inches. So maximum size of the footing for this building will be 6 foot 3 inches, that is for this column. Fine. So similarly you will have to go for the other columns as well. Normally what I do, I make a group. For example, this is 330, this is 325, this is 275, this is 224. I'll make a group of for these two, C1, C4. I'll make a group of all the 500s, 515, 502. All this will be same group, 521, 533. All this will be same foundation, 393, 396, and 400s. Any 400s here, 422. All this will be same, 441. All this will be same sizes. Yeah. So this way I'll make a group, and I'll not make more uh, different sizes of foundations, because it makes work quite tedious, right, and hectic also. So you would have to make it practical, as practical as possible. It should be easy in practical life. So this is how the foundation should be done. There's a lot of things which is going on in this, but right now for this video I'll only share till this. It's quite late now. I hope you guys, if you have followed till here, you are genuinely interested in knowing all those stuff. Follow my channel, follow this. I'm giving you genuine knowledge here. This is a practical knowledge and technical knowledge also. I have learned it all the way by working in site and doing all those practically. Hope this helps you a lot, and it makes me motivated, keeps me motivated if you can engage in this video. Thank you.